of a hiccup. Welcome to today's Common Lisp study group. Today we'll be discussing Chapter 7 and Chapter 8 of Practical Common Lisp, which discusses an introduction to macros. I'm going to be mentioning right now, before we get started, that the goal of this discussion is to provide not only an introduction to macros, but also to gauge interest as to whether or not we'd really want to delve into this for the next couple of talks and study groups. Primarily because macros is one of those features in Common Lisp that really doesn't exist and doesn't have I wouldn't say an analogy feature in a current modern programming language that's in use today, with maybe the exception of Clojure, and even there Clojure takes a different approach than what Common Lisp provides in terms of designing macros. In particular, Clojure and Lisp macros that are provided in languages such as Racket and earlier versions of Scheme, they use a different form of symbol resolution. This is where we'll start talking about, hygienic versus unhygienic macros. But to get started, I thought we would go through some examples that are in the book chapter, and leave it open for discussion, because honestly, this section is really basic in terms of designing macros and just talking about macros in general. What we won't be discussing today, and this is just another announcement, is how to actually debug macros and different ways of designing macros. Unfortunately, from my reading of Chapter 8 and Chapter 7, I didn't see anything specific in here on how to take those approaches to debugging macros. But there are other supplementary material, other books that do present that quite nicely. And again, after we're done with this introduction today, I will ask those of you who are online or who are available on the Lisp Discord server who are watching this, if you guys want to delve into the macro subject deeper, and if so, we will schedule those talks in order before we continue on in our exploration of Common Lisp via Practical Common Lisp. Does that make sense for those who are in the Hangout?
So as a point of note, it looks like some people aren't actually getting the live stream on YouTube.
Really? They have to do a refresh.
Yeah, okay.
The live stream. Once they get the URL, unfortunately, you have to refresh the link in order for the live stream to start. So let me. Unfortunately, I don't know. I think it's a bug on YouTube's platform, and I was going to make a note of it, but this is the second time I've seen this happen, where you go earlier before a talk starts, and YouTube doesn't start broadcasting it immediately. Some notification breaks, and you have to refresh the page to actually see the live stream.
Yeah, I'm sort of discovering that myself. I can get it on like my laptop, but oh, there it goes. Now it comes up on my iPad as well. Okay.
Okay. So, does that make sense for you, though, Elijah? The sort of the syllabus and point of study?
No, that makes sense to me.
Okay.
Also, it seems like one of our members is... Yeah, okay. Give me just a moment. I'm going to get... I only remember him by his screen name for some reason.
Don't worry. I will send it. I'll send it
okay.
to him.
Okay.
He's on. Okay, I sent it to him. He should come on shortly. Okay. So to get things started, while other members are joining in shortly, I just wanted to discuss in particular what Peter talked about in terms of different features in other languages and the macro feature in Common Lisp, and what it lends itself into a particular design to start things off a little bit. Other languages often, and I sort of start with C just because almost most modern programming language after C was sort of accepted as being the lingua franca for almost everything for years. Sort of adopted C's idea of having something called a core language, which is a very basic set of primitives and subsequent features to describe a machine model and an execution model. And then semantics on defining functions in some level of modularity. And on top of that, you would have your what you call the C standard library, which is effectively a set of nice functions and utilities that one can use to create programs. Now, from that perspective, and this isn't really touch base, but it is implied in chapter 7 in the introduction. You would be using a lot of the standard library features for, say, memory allocation, resource management, file resource utilization, and sockets and so forth to create your applications. But it's actually not part of the core language. But most application programmers don't make a difference. They consider it part of the core language anyway. It's sort of an abstraction, if you will, but it's not really in terms of its implementation. And the reason C and a lot of the modern languages take this because it's fairly easy to implement function semantics and function call semantics. In the case of Java or Smalltalk, I'll say more about Smalltalk than Java. Um, the extension is sort of the same way. You have a core framework, which is a set of objects, and then if you wanted to create applications, often you end up subclassing those objects and just implementing those messages, those appropriate messages where appropriate. Now, Common Lisp does, I will say at the outset, support both approaches, API design, as well as framework design using objects and object hierarchies. There is a third way of doing stuff, which is syntactic abstraction, and that is what this chapter and the next chapter in Practical Common Lisp is about. And the notion is instead of designing frameworks and sublibraries which create skeleton applications or ways of doing things, you create essentially an embedded domain-specific language, almost an extension of Common Lisp, so that it looks like a first-class citizen in the language, and write your program using that approach. And there are some advantages and disadvantages from this. We'll discuss those particular things when we start really delving into. But for now, know that syntactic abstraction is the design metric, and language-oriented design is the design approach that one leverages if they're using Common Lisp macros. This is something that I want to stress, just in particular because it is a design methodology almost. When I read and understood this, this is how I sort of see it. It's like an extension of the software design space. The case for it in Common Lisp in particular stems from the fact that a lot of the core, what we consider core Common Lisp that is indivisible, meaning that it can't be broken down any further, is really just a set of 25 operators. And a lot of the functions that we use on a day-to-day basis are more often than not either a macro or a function that was built on top of those special operators. The example that was given in chapter 7 to start off with is the if statement. So if we recall, if looks like you have a conditional, say, you're looking at, a dumb conditional like checking if 5 is greater than 4 and, printing it is or it isn't. And notice in this particular case that what I'm defining is a set of is the if, the condition, the then form, which is the form that is evaluated if the condition is true, and the else form, which is evaluated if the condition is false. Okay, this is pretty obvious for folks who have actually touched Common Lisp and started doing basic conditionals. Even other languages, this is familiar. But where it breaks down is if one wants to do, you know, multiple things in the previous statement in the then form. How would you run multiple statements sequentially in Common Lisp? Well, in other languages, what you would normally do is create a new block. You would end up, you know, using, like, say in C, an open curly brace and a closed curly brace, and create and have one or more statements or one or more expressions running inside that block, and then you would exit the block. In Common Lisp, what you have is something called prog-end. This operator allows you to create essentially the equivalent of a block. So in here, we would have our same statement. Let's say that we just want to add 1 and 3 in as a dumb example, and complete our expression. So in here, this block runs multiple statements in sequence of each other if the condition is true, and if it's not, obviously we run this guy. So here you can see it ran in sequence, it printed out it is, statement it is, and then evaluated the last expression, returned it. This kind of set of forms here is actually a very common thing in Common Lisp. So common that the standard what we call the standard library actually implemented something called when, which will allow you to run multiple statements in sequence the same way as before, and you don't need to actually specify an else condition, and it will just go ahead and run it if that condition is true. And obviously, if it's not, just to show you, we go in the other direction, it'll just return nil. Even if when was not there, and just to complete it, there is an unless, which is essentially the not version of if the condition is false, instead of if the condition is true. And it does sort of the same thing. So if we do this, you see, obviously it prints the not version of this guy that is highlighted. So since even if those didn't exist in Common Lisp, the utilities that Common Lisp provides gives you the ability to write these yourself. And that is, what are the advantages of that? Well, one, this is pretty clear. Anybody who reads this will clearly understand, from one perspective, what exactly is happening. You can run these sets of things when this condition is true. We're going to just keep running in sequence. And since it's wrapped around in a parentheses as a function call almost, it clearly indicates what the block of code is doing. Whereas if you saw our prog-n guy and you're not familiar with the language, you'll end up seeing this and not sure what prog-n is, and will often end up going and looking it up and figuring out, you know, what exactly is these different operators. And it takes a little getting used to actually figure out what those pieces of code are doing. So one thing, this is what Common Lisp, and this is what Peter was talking about, has creating your new control constructs, because essentially this is changing the control, is abstracting the control flow, a particular type of control flow, and making it easier for you to express what it is you want to compute rather than how it's actually doing it. this is the basis for other things actually too. And one of which is if you wanted, you know, a multi-branch conditional. Now, those of you in the newer language space, the switch statement actually uh, started addressing this with some range switches in some languages. I know Dart has this ability that you can actually specify ranges in the switch statement for different cases. In Common Lisp, for the multi-branch conditional, if you don't want to write multiple if expressions, where like you say if do this, if A do this, if B do this, and so forth in the else condition, you can do something called cond, which allows you to specify multiple conditions in a single statement. So you know, you could do cond if think of a particular case here that actually illustrates cond. Um, let's say that you are defining, you know, just an age greeting, you know, and you specify an age. You could say cond if, and you specify a condition if it's greater than, if the age is greater than 5 and less than 10, will then print a kiddo if it's, you know, between greater than 10, less than 1. Hey, buddy. And our default will be age unknown, generic greeting. So if we, you know, specify, say, something like 6, you'll end up getting kiddo. And then if we specify something like 15, you'll end up, you know, using the cons to create these multiple branches. And each of these, as you noticed in this particular piece of code in this function, I'm specifying ranges. Now, before, what you had to do in like C and other languages, you would have to use the if statement alone to actually specify um, these ranges, and then write the blocks of code. They've now since changed how the switch statement kind of worked, at least with respect to some other languages. And they've essentially adopted a lot of the semantics that cond provides. But this is another piece. But the difference is cond itself is actually just a macro. And you can actually see that if I do, if I do a macro expand, I can actually see that. Do that. Actually specify it here. You could see that the conditional expands and creates this nested if structure that we were just talking about earlier. And this is exactly what is actually printed out inside the book. If you guys review this, any questions so far? A lot of this is probably pretty much reviewed from what the book actually said. You'll see also some of the other conditionals like logical and or not are well, really and or they're implemented as macros to implement short circuiting as well, while not is just a function call. Finally, chapter 7 talks about iteration. This is the other place where you see things that are. Hold on, there's a question here from George. Doesn't cond execute only the first body after test returns true? So the options.
He's just saying you don't need to redo the test for the earlier cases and each of the later cases as well.
Right. Okay. Yes. That's correct. That is correct. You could do that. It's cond only executes the first body. There's some semantics in cond that I'm not really talking about here specifically for multi-branches. But yes, you are correct that after it returns true, it only executes the first body. So
and actually, you can kind of see that if you look at the expansion that it generates there.
Exactly, and this is where I was getting with macro expansion. You can see that this is a very simple case. If you're doing multiple, if you want multiple statements, of course, cond doesn't address that. You're going to in a particular conditional, and you'd have to implement the prog-in semantics to have multiple statements happening for each.
Actually, no. Cond does provide an implicit prog-in. It's one of those weird little things that people don't notice until they try it.
Oh, really? Hold on, let me try this.
Yeah, yeah.
Another statement, because I'm used to just doing prog-n just out of habit. So it automatically handles both cases. Okay, so this is another thing, like about macros. Macros give you the ability to hide different semantics based on different cases, and obviously, unless you visit the particular case that unless you actually have a case where you're going to do this kind of thing, you would never actually see that in the macro expansion. You would be none the wiser. So it's funny. You'll learn a lot about some things that are in different macros as you use them. And I'm talking about the standard library macros. And if you want to know how something that's already a macro expands to, this is what you would want to leverage, which is macro expand 1. Now, this is only for the first level expansion. It doesn't do multi-level expansion, but if there is a function where you can do multi-level expansion as well. And in fact, I think it's, if you're writing code, right now we're in the REPL. If you're writing code in a buffer, there is a Slime key binding or Sylvester key binding that actually calls the macro expansion of your Lisp and pops it into a buffer itself. So I do ask you to refer to the Slime manual and the Sylvester manual so that you know how to do that macro expansion when you're developing code inside your Lisp buffer, rather than popping it into your REPL, because it's just
Control-C and return on the form.
Yes.
There's actually another utility that you can install, which is called macro step, which will allow you to sort of in place do macro expansion. It's a little weird at first, but it ends up being really convenient for when you're experimenting, because you can expand just the macro that you want to expand in once and see it in the context of the rest of the code. It makes the buffer read-only, so you don't accidentally start overwriting generated macro code, and so you have to make sure that you exit out of it when you don't want to start editing the file again. But it's really convenient just to use. So that's something you may want to look into. It's called macro step mode.
Macro step mode for Emacs.
Yes. Yeah, and there's a further thing you need to install, specifically the version for Slime or Sly, because macro step itself is more of a framework for languages that have macro expansion.
Gotcha. All right. So, folks, there you have it. There are nice Emacs plugins for doing pretty cool stuff with macros. And again, as we delve more and more into this subject, we'll start looking at those. It is really a real boon, but you have to get used to some of the simple macro examples and what is currently available in the code to know how to really leverage this feature. And I'm still learning, as you can tell, about macros and how the expansion kind of works. So not to mention the tools that are available to do some macro development. So this is a really neat feature, but there's a lot of stuff that's already available for you, and try to leverage that. And you'll start seeing cases where a macro is the only way to actually abstract out code, and we'll see that when we're doing our practical project and designing a unit test framework, which is the next practical project in the book. Finally, I think really the iteration is something that really needs to just be addressed. So, as those of you who read the book are aware, and those who aren't, in short, Common Lisp never really, it didn't have necessarily a do operator, right? It had a very primitive Go facility, and macros actually were the feature that added a lot of the basic iteration constructs into the Common Lisp standard library, if you will. They have a very generic iteration constructs in the do form. And do is pretty complicated. I'm not gonna lie. So I'm gonna start with the other two that were built on top of that, which is do list. And do list essentially takes literally a variable that you want to specify each element of a list, takes a list that you want to iterate through, and just simply allows you to write a simple iteration across that list. Do times is the same kind of idea, except rather than specifying what you would normally do in C, you would write, for, int I equals 0, I is less than, some upper bound, let's say 10, and you construct the I, and then you run a bunch of stuff in here. In Common Lisp, you would just, in using do times, you could just specify the upper bound and then just run it, and it will essentially run 0 to, it'll exactly run the same thing as the comment that I wrote earlier. It'll go and iterate from 0 to 9. These two are both essentially just built-in macros that on top of the generic do facility. So if you want to look at, for example, what this generates, when we macro expand do times, you'll see that do times literally goes and becomes a do function. And do is just, this is your generic starting. This form here allows you to define your initial state and your step function for each variable that you're defining. Then after you define that, that could be one or more things. You have what's called a stopping condition. In this case, we're checking to see that x is greater than or equal to 10. And finally, we just go ahead and execute the code one at a time. In this case, we're just printing x. Now, of course, in this macro expansion, do times and other facilities will generate different types of ways of doing iteration and how to declare it for code optimization when code gets compiled. In this case, what's happening behind the scenes is the compiler recognize what type is being passed in, and realize that you can actually fit that into an unsigned byte and declares it so that it will generate the appropriate assembly code. So that's fairly efficient. But the key point here is you didn't have to know all that to really use do times. All right, you could just say, oh, do times is available. I could just go ahead and use it, and it'll generate all this code for you. But if you need a case to actually go and use do, you can go ahead and do that. And there are some situations where do is appropriate. So far, a lot of those cases can also be addressed when you're leveraging the loop facility. But do is powerful enough to handle almost all of your basic iteration needs. Finally, and honestly, I'm going to be. This is a very, very, very simple case of leveraging this feature. But for iteration, you also have the famous loop macro. Now, we later on touch base in the loop macro, and what nice facilities it has. And I would like at this point to actually make a note to the more experienced Lisp developers and make a request, because the common Lisp community has been kind of divided on loop. There are folks who are, who love loop. It's a great feature. It has a great domain specific language. It's very concise to write things. And and there are those folks who say it's not Lispy enough. It doesn't allow you to extend it. You can't write generic iteration facilities across object containers that you specify unless the primitive type that is already defined by the common Lisp standard and so forth. So there is an extension library called Iterate that essentially a lot of folks have considered to be kind of a successor to Loop. And unfortunately, I haven't had the opportunity to really delve into Iterate. And I'm curious if there are other folks in this call who have had a chance to play around with the Iterate library. And those who have, I do request that if it is possible, when we get to Loop, we will discuss the Iterate library as well, because that's actually just to show the differences. It would be useful for those who are watching this in YouTube or who are on this, who are in our weekly hangout to know what it is that Loop it doesn't have, but newer libraries do have. But to go back to what Loop provides right now, when you normally, implement, I'll go to the example that was in the book on this guy, because this is really shows what how concise Loop code can be and how clean it is. Take, for example, collecting a list of integers. All right, we have obviously what we would consider to be our collection. You have a step variable that starts at 1 that we would increment. And I'm going to go ahead and break this down here. And then we have, actually, we need just those two. Now, these are your initial state variables. And let's say that, we want to stop when, we get to 10. So we're only grabbing, the first 10 integers here. Common approach that we take here is we go ahead and this is a pattern that's often used. You start with a list here, and you start pushing items onto the list. This will generate a pretty. It's a pretty quick operation behind the scenes. And when you are hitting your stopping condition, what you do is whatever you collected, you end up just doing an n reverse. N reverse is what's called a destructive reverse. It does essentially the equivalent of set f, variable, and then you specify the return of that variable. That's the equivalent of n reverse, and it just returns it. But those of you who are looking at the loop facility, hold on 1 second. For some reason, kayak tab complete got created. You could do the same thing without even knowing all that by just saying for I from 1 to 10, collecting I. It does the same thing. Which one looks clearer for those of you that are on the call? I think this is obvious. This obviously looks a little clearer, although this probably generates the same code too as well behind the scenes. Again, macros allow you to define what to compute and makes it a really nice facility to actually express those computations clearer for maintainability in a lot of cases. And in this case, you're providing some nice features to explain what exactly is happening behind the scenes. So that's the basic controls constructs that are already available to you. Do we have any questions on that? Nope. Cool. Tanju, I noticed that you're on the call. Did you understand some of this, or?
No, thanks for asking. I'm behind, so I just barely started trying to read the beginning of the macro chapter today, but I am pacing, just behind. That's all. So no questions. Thanks though.
I'm just double checking, to make sure
Appreciate
those of
that.
you that are on the call, those of you who are in YouTube land or something, ask questions. We're here to discuss some of these things. It'll be interesting. I want to take a quick step back before we start discussing Chapter 8, because Chapter 8 reminds me of a article that I read a while back that I think Judd actually brought on, and that is the XML to macro story. Do you recall that article? It's for those of you who aren't familiar about this, the guy who designed the WebLox framework actually wrote an article back in 2006 talking about Lisp macros. And this particular chapter reminds me a lot of that article. When you're defining your own macro constructs, you're going to start leveraging a lot of things about S expressions. And those who've tried doing stuff in, say, XML or things where you're generating these intermediate representations, you'll often actually see a lot of analogies to this approach, and you'll end up realizing that we could have just done this we could have just done this using Lisp macro if we had a macro facility. I wanted to stop just a minute and Judd, if you can, take over and just explain a little bit about that that article. And you're on mute. And we can't hear you.
Yeah, we still can't hear you.
Looks like you're unmuted on Hangouts, but maybe your mic is muted.
Yeah. Nope, we can't hear you. Okay. Well, while you're solving those issues, I guess
microphone problems.
Yes, you gotta love the microphone problems. This is he's now trying to figure that one out. While he's trying to figure it out, I'm just going to give just a very quick brief introduction to the def macro function for defining macros. Okay, especially for those who haven't actually looked at this code, looked at the chapter, that is. We've seen def macros actually defined in other aspects of the book beforehand. It's pretty simple to actually define a very basic macro. It's just, you define the macro much like you define a function. You specify your arguments that you'd want to, take. And difference is whereas with a function, you just start writing Lisp code, form 1, form 2, To generate the code that ultimately is passed to the evaluator, you use something called the backquote. The backquote operator essentially tells the Lisp reader, if I recall, the Lisp reader, that it's these are expressions that are going to be returned. It's the equivalent of actually using quote in a lot of cases, but there is some semantics associated with the backquote versus leveraging quote alone. But then you just can type in your Lisp form as is and it will get evaluated and compiled as it's getting read through. But things that you don't want to be evaluated immediately.
Your mic.
Put the volume down.
Yes?
Put the volume down. Put the volume down.
Better?
No,
Yes. Oh,
it's getting better, but
yes,
it's a lot of noise on that mic.
There is a lot of noise in that mic.
Yeah.
Can you hear me?
Yes,
Yeah.
we can hear you.
Yeah.
Is the noise okay now?
Yes.
Yes.
All right. Sorry.
That's fine.
Close something else here. Okay, and so I can see you guys. Boo. Okay. So you want to keep going, Rom? Want to keep rambling?
I'll keep rambling just for a short minute, and then switch over to you just for a second. So stay unmuted, so you don't have any computer problems. Just very quickly, in the code that I was going to show you, if you don't want something evaluated, a single form, you use the comma operator, and for multiple forms, like in this, you'll get a list of forms when you pass in the rest into body. You could use comma et, and it will take the entire block of code, and it will just run them. It'll just stick them into that final body there. So if we compile this and then try it what we just did before, we can we'll see that we'll end up getting the same result.
As a note, when you define the macro, if you use ampersand body instead of ampersand rest, it does literally exactly the same thing, except you get 2-space indentation when you use it.
Oh, excellent. That's what I've been.
Just so you know.
So
that's how you do that.
This is the same thing, folks. Ampersand body is body, and in general, like when you're designing macros, you'd want to use ampersand body. I mean, they're the exact same thing, but ampersand body gives you some nice, pretty printing too, like Elijah said, and that is. I've seen a lot of code that use that, but when I hear that they're the same thing, I've often used ampersand rest just because it's easier to remember a single set. But when you're designing macros, ampersand body is probably much more useful. So as you can see, our macro work just has our when macro that we saw earlier, and as before, when we expand this guy,
Note the change in indentation.
Yes, noting the change in indentation. Thank you. in the REPL.
Although in that case, it looks like it's just not doing the indentation at all, which is weird.
Because this is actually generating, this is macro expanded to what we defined earlier, with everything obviously just inserted in. So what macros are defining is a code template almost that's in a lower level version of your Lisp code. So those who are familiar with, say, Ruby, I would say there's a semi-decent analogy to it, but I wouldn't even go that far. This is completely as if you're writing your own meta compiler on top of the core common Lisp language. This is what you're generating. This is what's what's called in the compiler world, I would say that this is kind of close to syntax-directed compilation. You're letting the syntax generate a new piece of code and template, but it's in a lower version of Common Lisp, so it's still Common Lisp at the end of the day. It's not, assembly code. So it allows you to create these declarative constructs as a result. Judd?
Okay, I'm just waiting on coffee. Can you hear the coffee machine, the microwave in the background?
Yes, I can. Go ahead.
Well, soon you won't be able to. All right, you want me to go and start
Yeah,
talking about this article?
Yes,
Okay.
go ahead.
Are anyone besides Rom familiar with this? Elijah, you might be. You sound like you. Anyway, the article basically describes the authors coming to grok or understand Lisp, and the article author relates a story of a developer. Let me see if I can get the guy's name. Very famous, apparently. James Duncan Davidson. And he was working on with some Java thing called Tomcat that I don't care about. But the important thing is that while the developer was using Tomcat, he was having this problem, and he really, really, really couldn't deal with it until he found out that the problem was that I guess his make job was blowing up because he used some spaces instead of tab characters. So that really pissed him off. So he decided to make his own make tool, and it was called Ant, which stands for Another Neat Tool.
Right.
And instead of using text, instead of using just text and strings and stuff like that to hold data, it used XML as a way to store stuff, right? Then the article goes through some arguments where, okay, well, XML is hierarchical and regularly structured, and then you can also encode functionality itself. So XML, vanilla XML concept is basically, it's just data, and it's supposedly human readable and things like that, but it can also encode functionality. So you can use XML transformations to do stuff to your XML code. So wait a minute, if XML can encode functionality and operate on itself, then, oh my gosh, this looks a lot like Lisp, right? So there's a very clear correlation between the structure of something, either data or functionality in XML, and how you could write basically exactly the same stuff using S expressions in Lisp. And so then, that just, well, if I can define the functionality, I can write programs in XML that get used by XML to operate on XML. Oh my gosh, right? So it drives towards the question and the point, code is data, and data can be considered code, right? So anyway, it's a nice introductory article to run people through the data is code thing, as well as the power of Lisp being able to operate on itself, since it's homo-iconic.
It's always a fun word.
Yes,
I know. I swear to God, I want RuPaul to be our mascot. RuPaul's favorite language is Lisp.
The reason I bring up this particular rambling from a long time ago is because for those of you who probably went through all these different make tools and build tools and the years of leveraging XML for generating different web formats, XSLTs for doing transformation between one XML document to another XML document, Maven for dependency management. A lot of those are essentially DSLs that were written inside XML with a preprocessor that ends up compiling it to something that's nice, and it's just taking something that is a tree expression and generating a new format. And having S expressions and being able to do that in the same, self-hosting manner like this article brings out in the case of Ant, really changes your entire perception on how to design your system. Now, again, things can go overboard, just like with everything else. Like I will say, and this isn't discussed in the chapter at all, but it's often discussed on Lisp forums, that there are folks who overuse macros, like they don't know when to use it. There's cases where sometimes a simple higher order function will do. Knowing when and where macros make sense takes practice, just like anything else. Much like when and where creating a framework for just everything, where you could just use, like, say, a simple data structure and a simple algorithm, also takes practice. So, if at the end of this discussion you're hearing me say, like everything else, this is another design methodology, then I've done my job. I've actually, showing you that Common Lisp has this nice feature. It's really, really useful, especially in Common Lisp, and but as with every other design methodology, one must understand when and where it gives you the biggest bang for your buck, and that takes practice. As we go into some of the other aspects of the Common Lisp system, in particular, things like the Common Lisp object system and the meta object protocol, and some of the uses of high order functions, you might end up seeing cases where, oh, you could also do this with macros. And in some cases, when they were experimenting, I'm pretty sure they implemented it with macros. But that being said, it might be just better to leverage the current standard facilities that are available to you, and then do some engineering and benchmarking and figure out if something better is required or if it's good enough for your system's design. So this is, like I said, a very basic introduction to macros. And we can go on with some of the examples that are provided here. But I wanted to stop before we start talking about one of the more famous macros that are mentioned in Chapter 8, especially for those who are just starting to learn some of this macro stuff, and that is the once only macro. Once only is a macro that we need to sit down and really discuss.
Once only is the sort of macro that I take a whiteboard out and walk myself through once every couple of months to make sure I still understand it, because it's
right.
Once only, in my opinion, was introduced way too early in Practical Common Lisp, and you're perfectly free just learning that it's there and that it exists in a number of standard utility libraries and when you should use it, and not worrying about how it works.
I second that very strongly.
It's
The way I treat it is I read once only once, and that's the only time I'm going to read it. I know it works. That's all I need. It's like loop. You don't need to know exactly like the expansion or how loop expands precisely for 99% of the time. 99.999% of the time, just because the specification of loop is enough to, that gets you what you need. Like you said earlier, you don't need to know how do list expand or do times expands. You just need to know the API of, it. But that being said, a lot of times examining macro expansions is useful in learning techniques for writing your own macros, which is, one of the reasons why once only is in there. But I completely agree that it's probably way too early for such an advanced macro to be in there.
It's one of those macros. This entire section. This is why I'm for this introduction, I'm being very careful on teaching macro writing macros and the concept of once only. For those that are listening in on this, yes, I know that we should talk about it eventually. I don't believe in our journey, in the current step in our journey, like everyone said, that that we should start discussing GenSim and hygiene and stuff, just because you need to get your feet wet. You need to understand that there's a lot of cases where simple macros will do, and knowing how simple macros work, because it'll help you understand other aspects of the common Lisp system that are available to you. Obviously, as we start designing macros and go through a more thorough macro tutorial, this kind of stuff has to be shown, because it's like the foundation of good macro design, especially in Common Lisp. But I don't want to confuse folks at this point, thinking that this is a very important concept. It isn't at this point in time necessary for you to actually know how once only works, how GenSim works, and the notion of hygiene just yet. Just because in the next chapter, especially when you start talking about designing the unit test framework that Peter goes through, you're only going and leveraging simple macros. You're not leveraging any of these other things.
I would like to note on the other side of this, though, is that it is important to know just how ubiquitous macros are. They're basically everywhere in the standard library. You can throw a stone and you'll probably hit a macro.
Right.
I mean, like, defun, def macro, do, loop, cond, case, type case, def class, def method, def generic. These are things that we'll be getting to eventually, of course. The point is that there are a lot of definition macros, for one, but macros show up basically everywhere, and it's important sort of to realize, even if you're not writing a whole lot of them, and the truth is you don't generally need to write a whole lot of them. They are everywhere, and realizing what they do and how they work is important, just to make sure that you're not surprised when things violate your expectations. You have the tools to sort of wrap your brain around what's actually going on. And so there's just the fact that the macro facility is there and so widely used throughout the standard library makes it alone enough that you should have at least a passing understanding of what they do, how they work, why they work, that kind of stuff.
Right, and to add on that, knowing how to expand macros is definitely useful, and knowing how to debug macros is definitely useful. And these are things that will help you to debug your code and make it as efficient as possible on the Lisp implementation that you're leveraging. But some of the more advanced facilities, again, I repeat, just not to beat a dead horse, but it's right now, because they're universal, you just need to know that they exist, and a lot of other facilities leverage them, but that's about it right now. So those who haven't had a chance to go through the second half of Chapter 8, the sections on with GenSims and GenSim and once only, I do encourage you to get a passive understanding on that, but we will address this at the correct point in time, based on where it is necessary to start talking about it. And you can get pretty far in learning the language and what libraries are available and designing pretty decent Lisp applications before you even start hitting this this part of the Lisp system and your Lisp understanding. This is a very advanced topic that you'll only start getting into designing it when you're designing your own libraries and your own infrastructure, and you're not leveraging someone else's, or you're trying to debug someone else's code. So with that, I'm going to stop here with the basic discussion of the chapter, and I'm going to open the floor to other questions regarding macros that may be, in your minds. I'm going to preempt just one of them, and that is, Well, we specified if conditionals and control constructs. What other things can macros kind of do? And to allude to what Elijah said earlier regarding it being, so blatantly used everywhere in the standard library, it's often used for even things like, say, resource management, like opening up a file and closing a file. You will often never write a let statement that opens up a file with open. I more than often leverage something called with open file, which automatically opens it and puts it into a particular stream. If we look at the signature, it'll create a stream that you wanted to leverage, and you specify the file spec, which is like the path name and so forth, and you specify the direction that you're leveraging that file with, whether you're using an input like you're writing it, reading from the file, or an output file where you're writing to the file. And all these options that are available in this macro are actually passed down to the lower level functions that actually open up the resource themselves. And this is a common practice that you will see it in a lot of places where you're dealing with resources, a with macro being available just for that particular type of resource. But it's there, and it is. If you see a custom resource that you've created, like a singleton object that in your system that you want to isolate, where you're doing simple transactions, you can build that using these kinds of with macros that are and you can design those. But again, we'll get to that point when when at a later point in time, because it's not, you don't need to know about that particular section of designing those complex style macros, but they're there. Questions?
I don't have a question, and I don't want to, prevent anybody else from asking questions. Obviously, this is just if we have a little time. I actually have sort of a standard little demo that I like to walk people through when just getting their feet wet with the whole homoiconicity code as data sort of thing going on in Lisp.
Go for it. The floor is yours, Elijah.
All right. Let me see if I can't share my screen, actually, if you don't mind. I won't be able to share a particular application because that'll be difficult just because of the way that I have my system set up. But I can share my whole screen. Is that coming through to everybody?
Yep, you're good.
Okay, cool. So what I have here, and just actually, this is what I was playing around with earlier. I just have a file over here, and over here I have my good old REPL. This is Sylvester or Sly or whatever you want to call it. So it looks. Why can I not hide that? That's annoying. Something to play around with later. So it's similar to Slime. It's just a REPL. So when you're working with Lisp, you've got the parens and all this kind of stuff. Print, foo, all of that kind of stuff. And what's actually going on here is and just sort of touch on this is, so we have loop, right? And we were looking at loop earlier with the more complicated loop invocations, loop for I, in some list, etc., repeat n times, or all those kind of things. But if you don't give any loop keywords, it'll actually just keep looping forever. And that's useful because there are ways of breaking out of that loop, just in regular Lisp code. So if you don't want to leverage any of the loop facilities and you just want a quick infinite loop, well, this will do that for you. And I'm going to just pull out some stuff here. Read, that's the one, right? So if you note here, I've got, this called this read function, and I'm taking the result of that, and I'm passing it to this eval function, and I'm taking the result of that and passing it to this print function, and then I'm wrapping all of that in an infinite loop. So if I hit enter on that, some fun stuff starts happening. As you can see, I now effectively can give Lisp code, and it comes back to me evaluated. And let me just break out of that real fast, because remember, it's an infinite loop, and I didn't actually provide a way of escaping. But the important point is that this right here is actually the fundamental REPL. It's a read, evaluate, print loop. And the thing that makes this possible to express so concisely, I guess you could say, is this fundamental property in Lisp, which is that code is represented as a data structure. And so if I just call the read function on its own, and actually perhaps a better way to do this would be for me to create, some little test file, and I'm going to put some, S expression in this test file, and I'll save it. And let me just set my current directory to make sure that I'm in the right place. Dropbox, junk, 2018, 1. That's the one. And I can't tell what I named that because this stupid thing is covering over the file name. So now, I can say with open file.
Elijah, sorry to interrupt. If you want to hide that Google Hangouts thing, it says hide right next to
No,
stop sharing.
I clicked on it multiple times and nothing happened.
Oh, really? Okay, that's
Yes.
a bug. Okay, I'm
Yep,
making
I
a
know.
note of it.
No, it's probably something weird with the way that I've got my whole system set up. It's very likely on my end. I run a very weird setup here. Give me just a moment.
Go on.
Nope. Sorry about that. There we are. So, I can do, with open file, I'll just call it, test, and I'm going to be opening this test.txt file, right? Good old with open file. Here I'm going to do is I'm going to read from this test file. So is this clear to everybody what I'm doing here? I'm opening the file, I'm storing it in this test variable, and then I'm calling that read function with this, open file. Before, when I was calling the read function up here, I wasn't passing in anything because I wanted it to read from the standard input. But here I'm specifically reading from some file. If you note, what I get back is, this list that I had in the file, but it's now a little different. What's different about it, and let me define a little global variable here, form, and just store that real fast. So now if I look at my, form variable, it contains that list. It's not text. If I just, opened the file and done a read line, what I get back is this string, this string that contains that form. But, when I open it and I do, read, it gives me back it, without the quotes. And the reason for that is it is actually a list. So I can do things like ask for the first element in it, which is, plus, or, the second element. Go back to using my little local variable here, or global, I guess. REPL local. I can, get as many of those as I like. The important point is that it is just a list, right? When we're working with the other list things in the standard library, I can make one of these using just the list function. You'll note that I had to quote that plus, and the reason I did that right here, I had to, is because if I don't quote the plus, it will treat it like a variable, and it'll go look up the value of the variable, and that's not what I want there. I want, the actual, the symbol plus, and so the quote mark there lets you get that. The value of this list is now I can actually pass that to the eval function. I can evaluate that list, and it will, go by the standard Lisp evaluation rule. It'll take this, plus symbol. It'll go look up the function named by that symbol, and it'll give it these arguments and run that and give me back the result. And then, of course, back in our REPL, we had that, call to print right here, back in our little local REPL. And that's just so that, the result does actually come back to me every time. That otherwise, I wouldn't be able to see it. And so, I can print that, and it'll print out that 6. So, you can pass around this code as a data structure. And the interesting value to that is it means that you can manipulate your code using the standard list manipulation functions, right? And so what's kind of interesting is that I can actually do the whole test there, the whole REPL on this file just by evaluating the result of that read, right? And now we have this interesting thing here, which is that I'm actually opening up this file and running the code in it. Well, I'm running one expression in it. If I have another expression down here, print foo, right, and save that, it's still only going to run the first expression, because read goes and finds the first valid Lisp expression and it parses it, and then it returns that as an object. And so it doesn't bother with the second one or the third one or whatever. So what I need here is some kind of loop. Back to, reading, evaluating, and looping again. So I can come back here, and so the simplest way I could do that is I could just stick a loop there, right? And that'll work mostly. If I did get foo back, so it did get all the way to the end there, except now I'm in the debugger. The problem with this is that I hit the end of the file and I tried to keep reading. So I have to go a little further along. And I have to be basically just a little sneaky here. And I'm going to use just one of the extra arguments to read, and you don't have to really know what this does, except it makes read, instead of erroring out when it's the end, it returns nil, right? And so I'm going to say, loop, or what's the best way of writing this concisely? For expression equals read. This is a quick way of, I'm basically saying, each time to the loop, run this function, assign it. Right. Then I'm basically just going to say, keep doing this loop while there's some value in expression. And each time, evaluate the expression. Oh, right. I didn't actually tell read that it needs to not error out, and instead return nil. So if you note now, it ran all the code in that file. This first thing here doesn't print anything, but if I were to wrap it in a print and save that and rerun this, we get both the 6 and the foo back. And so the neat thing here is what I've basically done is re-implemented the common Lisp function load. Mine returns nil instead of t, but that's because I didn't read the spec for load, and I've forgotten a couple of details about exactly what it's doing internally. But the core idea here is it's basically going through, it's reading off one expression at a time and evaluating it. And the cool thing about that is, we can, if we can get something in between this read operation here, right, and the evaluation operation here, we can manipulate that like a data structure. So let's say if expression is a list. There's this function called listp. Will tell me if the expression is a list. Pretty sure that's yep. Listp. If it's a list, I want you to do something else, which is print the first thing in that expression. Now that we know that it's a list, we can ask for the first thing and we can print it out. So this still does the same thing here, but now we've got both of the prints. What I've effectively done here is I've gotten into the evaluator and I've inserted something between parsing and actually executing the code. And this is kind of what a macro is doing, really. I'm getting in there and I'm manipulating the code while it's a data structure. It's already been parsed into a bunch of lists, and it's easy for me to manipulate just using the standard library functions. But it hasn't been executed yet. It hasn't been evaluated. It doesn't have a value. And so, I can sort of play around with the code in this sort of intermediate space. And that's sort of what the fundamentals behind the macro facility are. Is that the evaluator, when it's going along, if it finds a, when it looks at the first item in a list to evaluate it, it'll check to see if that is a macro. And all a macro really is a function that knows how to take in some code and spit out other code. right? Which is a little weird at first, but when you realize that code is just lists, all it is a function that takes in some lists and spits out some other lists that you've given to the compiler and you've told it to use anytime it comes across this particular name. So
right, and I just want to bring up a point here because
sure.
that is a very good point to illustrate. If you actually to show just how simple this is, that everything in is list. If you look at the simplest example of this, this is actually shown in other macro tutorials that one may see after you do a simple search. You could just evaluate a list where you pass in an atom and a bunch of data and pass it into eval, and eval will just go ahead and evaluate it. And all we're doing here is creating a heterogeneous list structure where the first element is an item, an atom that's illustrated by the symbol plus, and 1 and 2. And if it can evaluate it, eval will just go ahead and take that entire list structure, pass it to itself, which is a valid Lisp object, and go ahead and evaluate and return the result. So you could define certain things that way. Of course, obviously, writing code like this, where you're specifying massive lists, is kind of tedious amongst being somewhat illegible and not sort of understandable for some folks. Having this S expression syntax being like something as simple as passing in list using the quote operator is very, very useful. And you could do the same thing here, and it will go ahead and take that list structure, pass it into eval, and that's just a shorthand to be able to take in Lisp expressions and send it to eval. And I think that's what Elijah is. And correct me if I'm wrong. That you're essentially pointing out, like this structure, this generic structure, gives you that ability to actually then take, and create, macros and create higher level constructs that will really declare how you're defining your program.
Yeah, basically. I mean, it doesn't get a whole lot more complicated than that. Yeah, I mean, in practice, of course it does, but in practice, so do functions,
Right.
A good point that Elijah's short demo made is something is being parsed into a structure, and then in that intermezzo, you can do whatever you want before you hand it off to eval. So it'd be funky to like take something and then you have it in the data structure, and then if it can translate it from one human language to another, that'd be interesting.
Oh yeah, there are all kinds of
show off that, oh look, I'm not kidding, you really can do basically arbitrary manipulation of your syntax tree.
Yep. And it really it's kind of weird because you're I guess weird isn't really the word, but it's strange coming from other languages because you're just not used to having syntax represented at such a fundamental level, right? As just part of the data structures of the language. And it makes macro writing a lot easier at the expense perhaps of making the syntax a little less friendly at first if you're coming from other languages, I guess you could say, because it is so stripped down. It is, just the list syntax, right? The list syntax and then the syntax for, your numbers and your strings and such. But this lets you very cleanly take that and go to a data structure that you can then manipulate with your code. And that's all a macro really is it's a function that manipulates your code as if it were data. And there is sort of one other thing that I kind of wanted to do with that, which is how exactly is the best way to go about this, is like the before when we had like the back quote syntax, right? Back quote, if, comma, conditional, prog, and comma at, body, right, which was the body of our macro, right? So I'm just going to come over to my test file here, and I'm going to define a function that does that. Define expand when, and it's going to take a, condition and a body. Yeah, no, that's fine. And here I'm just going to, do that if, comma, cond, prog n, comma at body, and I'm going to compile it in. So, now I can make use of that over at my REPL. So I can say expand when, and I can say, 5, 6, and then, give a list of expressions. So, print low, and then, print goodbye. And there it is. It generates. Did I not write that correctly? Oh, no, I didn't. I am being silly. I don't give a list of expressions because I have this take a rest argument. I do have to quote these individually now, though. And so, if you note here, it gives you the if, and then the condition, and then the prog n, and then the two sub-expressions. But this is just a function. So, I could have a, I can, pass in data to this that I generate on the fly. I could, say, have this be, a list that starts with the symbol print and, has goodbye instead of quoting that. Now we're starting to run into that. So I'm going to split that there and shrink that down there. And so now we don't have to deal with this stupid little thing down here. But this is just a function. And it still works the same way. It's just a data structure. But then I can come over here and I can define a macro called mywhen, which takes, that same cond. And this time I'm going to use ampersand body, if only because it makes my life a little easier indentation-wise. They really are equivalent, except for the fact that one hints to anything that's inspecting the environment that that's actually a code block. I can say in my macro, expand when, and then just pass in the cond, and oh, right, actually, there's a good reason for this not to take the rest argument. Let me change that to not take a rest argument and go back to my first version here, where this is taking a list of expressions. And, see, there's that again. Because this has already turned the multiple expressions in the body into a list for me. And so I can just come over here, and I can say, pass in the condition and the body to my expand when. Now I can say my when 5 is less than 6, print low, and, print goodbye, right? And so I haven't really, done anything except effectively use this function that I wrote as part of this macro. And all that does is it takes us into the compiler. It sort of takes us a step further down. It's still code is a data structure. It's just, now I'm manipulating that data structure inside of the eval function, because the eval function, is extensible. It knows when to look for a macro. That's sort of the very basic idea there. That's all I really had to say, I guess. But it's neat when you see that you can just write functions that manipulate code, and then turn those into macros.
Well, the real interesting thing that you just showed, though, in what you presented, Elijah, honestly, is the fact that one can just simply create functions to generate code based on particular conditionals, and then, have one big compile system, right? You'll literally, it's an intermediate step that based on what you're defining, they'll generate the code based on some particular specification.
I would
just
like
pass
to know
in.
one little thing. The code that I just wrote there will work unless you try and use this macro inside this file.
Right.
There's some little bits of weirdness that happen when you try to use a macro in the same file it's defined in, and this code right here needs a few little extra things set for it to work properly in that case. Just warning everybody of that. I won't go into what they are because they're beyond the scope of this, but in practice, you'd need to take the expand when function and move it to an earlier file so that you make sure it's loaded before the macro gets defined.
I think that's this really is the heart of what all of this macro writing is about. Like this ability to be able to write these kinds of like generic like expressions, templates almost, and based on what you currently want, you could just define. You could just call that appropriate macro to generate the appropriate set of code to be evaluated. And what's useful about this is, and I'm just going to make this last point. It is from like, for those who are like into like artificial intelligence, this makes things like genetic programming and being able to write like a control specification and an objective function to evaluate different sets of programs based on what you want it to do pretty simple and pretty straightforward because of this facility. To write the exact same thing in other languages, while doable, will take a significant effort. And with Common Lisp and in general Lisp that have a macro writing facility, but we're going to be sticking with Common Lisp in this discussion, you have that power available to you at your fingertips. You just saw from Elijah's demo that you could quickly create a REPL within one line that will take Lisp objects and evaluate them. That makes it easy to write your simple, Lisp sublanguage like the Lisp.py that was provided by Peter Norvig in a couple articles, I think a couple years ago. You could do the same thing in like a one-liner because it's already built in. You have that ability to do it. And I think as we delve more into macros, you'll start really seeing the usefulness as we address it in some of the practical projects later on. So we're hitting the hour. We're just going a little bit over here, but I just wanted to ask one more time for some of the newcomers that are available around if this gives you a nice overview of Common Lisp macros, and if you're interested, would you want us to discuss about this particular piece a little bit more in detail, or would you like to go on learning from the book just to keep going on inside it so that we can complete the actual book itself? So I'm looking at you, Michael, Tanju, and Judd.
Yeah, like I said before, I'm up for either.
Okay.
I can go either way, whatever.
I want to learn more.
You want to learn more. Tanju, do you want to learn more of do you want to keep going with practical Common Lisp?
I don't know. I really don't have good context, so I guess I'm good either way. I'm really appreciating the content so far. So
cool. I think with that, let's finish chapter 9, which will give you some practice on unit testing, building a simple project that leverages a lot of stuff that we did, which is functions and basic macros. But then after that, we'll try and do a more detailed macro introduction, just write a few macros in the coming weeks, so that we could start really delving into how to design macros and how to debug them. I think that's
actually interestingly enough, the unit test framework chapter itself defines a couple macros, so it'll be good practice, I think.
Yeah, exactly. I think after looking at the unit testing framework chapter, I took back, like, if we finish the unit testing chapter, we could then have a point of discussion to actually start talking about designing macros and debugging them, which will bring in another book, but I don't want to confuse folks right now. But more on that later. Thanks all of you for joining. I'm sorry that we went a little over, but join us next week again. You know, same bad time, same bad channel. Make sure that we get our practical experience going, and we will be covering Chapter 9 in Practical Common Lisp, which is designing a unit testing framework. So until then, thanks all of you for coming online. See you guys later.
Great. Thanks a lot. Bye-bye.
Bye then.